Hello and welcome to my presentation on atomic structure and bonding, where we will be covering the formation of ions and ionic bonding before moving on to how covalent bonds form and subsequently the different types of covalent bonding. We will also look at how different types of bonding affect the properties of different compounds. Ions are created when atoms lose or gain electrons, becoming positively or negatively charged. They do this in order to become more stable. We call negatively charged ions, which have gained electrons, anions, and positively charged ions, which have lost electrons, cations. Scenario 3 states atmospheric ions are electrically charged particles which occur naturally in the atmosphere. They form in the upper atmospheric layers mainly because of the action of ultraviolet radiation from the sun, as well as in lower atmospheric layers as a result of radioactive radiation and cosmic rays. These cause ionization of neutron molecules or atoms. As a result, ions are formed. These ions almost instantaneously combine to form molecules with ionic bonds. Now that these atoms are charged ions, they are electrostatically attracted to each other. Anions and cations become ionically bonded together through this force forming ionic bonds, compounds. An example of this is sodium chloride. As you see, the electronic configuration shows that sodium can become stable with one less electron, and chlorine can become stable with one more. Sodium loses its electron to chlorine, becoming a cation, while the chlorine atom becomes an anion. The opposing charges attract, forming an ionic bond. Many ionic compounds are crystal salts formed of metallic cations and non-metallic anions that have a giant ionic lattice structure with a high melting and boiling point due to a high amount of energy needed to break the strength of the electrostatic attraction of ionic bonds. They dissolve in polar liquids such as water and can conduct electricity when molten or dissolved as their electrons are free to move and carry the charge. Scenario 4 states a polymer is a substance which has a molecular structure comprising of a large number of identical molecules covalently bonded together to form a long chain structure. Many synthetic organic materials are polymers, such as nylon, polythene, and Kevlar. A covalent bond is also formed by electrostatic attraction, this time between the positively charged nucleus of each atom and one or more pairs of shared negatively charged electrons. Covalent bonds occur in non-metallic elements like hydrogen, carbon dioxide, and polyatomic ions such as ammonium ions or carbonate ions. Covalent bonding and ionic bonding differ in how they share electrons and subsequently bond, with electrons being donated and ionic bonding differ in how they share electrons and subsequently bond, with electrons being donated and received in ionic bonding and electrons being shared in covalent bonding. Here we have two examples of single covalent bonds in dot and cross diagrams of hydrogen and methane. You can see that in the hydrogen compound, each atom of hydrogen provides one electron that they share, while in the methane diagram, the methane has a single pair covalent bond between each hydrogen atom and the carbon atom. Double covalent bonding is when there are two shared pairs of electrons forming covalent bonds. Examples here include carbon dioxide and oxygen, which each share two pairs of electrons between them, here and here. Nitrogen and hydrogen cyanide are examples of triple covalent bonds, where you can see again in the dot and cross diagrams that they share the three pairs of electrons. Dative covalent bonding, or coordinate bonding, is when electrons being shared between the atoms are both provided by the same atom. Examples of this include carbon monoxide, where both of the electrons in one of the pairs of the triple covalent bond are provided by the oxygen, so these are the top one here, and hydrogen. Another example would be nitric acid, in which one of the oxygen atoms bonded by nitrogen doesn't provide, any of the electrons to the covalent bond. All covalent bonds are either polar or non-polar. Most diatomic elements, such as nitrogen and hydrogen, are nonpolar as they are equal in electronegativity and therefore share electrons equally. Water and hydrochloric acid are molecules made up of atoms with differing negativities, meaning that the electrons will be unequally shared and each atom will become slightly charged. These are polar covalent bonds. Covalent bonds are most commonly found as either simple covalent molecules such as water or carbon dioxide, or giant covalent structures such as those that make up diamonds and silicon. Both molecular structures are insoluble and poor electrical conductors, with some exceptions such as graphite, but differ in the fact that simple covalent molecules have low melting and boiling points due to less energy being required to break the bonds, whereas giant covalent structures have very high melting and boiling points due to requiring a lot more energy to break more molecular bonds. This brings us to the end of my presentation, where we can see my references and bibliography. Thank you for watching.